solo mining journey.
All right, cool. I'll do the screen record too. Um, and I think it's doing the audio. So, all right, cool. Let me share my screen. Hopefully, I don't have any problems with that. All right, great. So you can see my slides, right?
Yep.
Okay, cool. So I'll present it. You can still see the slides too, right?
We only see the presentation, not the
All
slides.
right, yeah, that's good. The full slide. Yeah, yeah. All right,
Yeah.
so we're in presentation mode. All right, so I titled this talk Mining the Hard Way, Solo Mining at Scale. And really the purpose of the talk is to sort of go through what it takes to set up a solo mining operation. It's a little more difficult than just getting the miner and getting a mining device and connecting it to a pool. There's actually a lot of other things that you need to do in terms of networking and configuration. And then with DigiByte, there's a little extra because of the 5 algorithms. So there's like some more you need to do around that if you want to, be able to mine on multiple algorithms locally. So I'll go through sort of the evolution of proof of work mining. I think it's just useful, some background. So basically, mining, as most people are familiar with now, is a mechanism to secure the blockchain. This idea that if you wanted to sort of redo the history, you'd have to redo all of the work that's been done. And then the idea of the fastest chain is sort of like the canonical chain. So once mining comes out, the original Bitcoin client had a miner baked into it. That miner was not really optimized. It was mostly just part of like the original proof of concept. That's like, yeah, here's the miner. And so from there, people have sort of taken it up and sort of modified hardware, modified software, and you get to this point where we have like really competitive environments for mining. So the way that this sort of progressed, you have sort of naturally with any proof of work chain that came after Bitcoin, they all sort of follow this hardware progression. And not all the time do they reach the end, but for the most part, they release a CPU miner client, and it's pretty inefficient because it's just using a CPU. CPUs are just general purpose compute devices, so they're not necessarily optimized to do this kind of thing. It's a little bit more difficult. It's very easy to create. That's why they're first. From there, you then get people creating the GPU mining clients. It's much more It's much faster because you have parallel processing. That's sort of the core hardware mechanism on the GPU. Is you have these like massively parallel cores that run. It's just that it's much harder to write software to target the GPUs. You need to write like CUDA code. So there's just less people that will know how to write software for the GPU miners. And then even faster, you get down to FPGAs. These stand for field programmable gate arrays. And basically, these are devices where you essentially etch the code into the hardware itself through like a firmware, basically. And the reason that that's faster is because these FPGAs are, you're etching it into the hardware. And the other thing about it is that you're essentially getting a higher clock speed, like really fast clock. So the FPGA miners, because you have to write firmware that then gets uploaded to the FPGA, system, it's even more complicated to write. But again, it's also much more efficient. These hardware devices have really fast clocks, and they can do a ton of computations. Each level here, you just sort of get like exponentially better. And then each level, you really only reach each level once the economics make sense. So like, for example, it's on a network that I used to be on, there was an early miner, everyone was doing GPUs. And then eventually the network became, worth the investment that someone had hired an FPGA developer and then invested, I think it was like 10 or 20 grand to have that FPGA developer create the software. And then he was the only guy that had that software for a short period of time. And then other people made that investment. And then, of course, the last one, which is where most Bitcoin is now, and all the other networks that are high end are at ASICs. So these are application specific integrated circuits, and they basically create or fabricate chips that have the circuitry just for doing this. So like the SHA-256 chips, script, a lot of other algorithms have it. And some, algorithms are more or less like resistant to it in terms of how they work. But for the most part, you could make custom circuitry for almost anything. And then yeah, the last little bit I have here is just like it doesn't reach each of these levels until it's worth it. So yeah, for ASICs, I think at this point you basically have ASICs that will work for DigiByte. Some of the algorithms might still have FPGAs, but so on the software side, similarly on the software side, basically it's initially it's just whatever the team made. So if Bitcoin Satoshi made, it's a client software. You would just run the node, and the node itself would have basic mining functionality in the software. Things like pools, things like reducing the latency by software upgrades. Those all sort of come later. If you have ASICs circuits, one of the key things that you can do is actually they come with essentially the firmware that actually squeezes out, doesn't change the hardware, but it squeezes out a little bit more performance because it optimizes the software. They also had to have optimizations in terms of how the mining clients communicate with each other. This is sort of where they introduced Stratum protocol, so better network communications, ways to sort of connect multiple miners together and work in a synchronized way. And that's sort of the last point here is just that you get to this point where more or less everybody uses the Stratum protocol, which is a way of distributing work to a bunch of different miners in such a way where nobody's like repeating the same work. It also has a way that it can prove that the miner that's gotten the work is solving the problem and then giving it back. This is the idea of like shares. Everyone you sort of get a proof, and then the idea of like difficulty tuning where miners that are faster actually get to work at higher difficulties, and miners that are slower, work at different difficulties, all to sort of reduce the amount of network communications. So they sort of optimize the protocol, the communication software, they optimize it so that you're using less internet. Mining, if anyone's done mining, you realize you don't actually need a super high bandwidth internet connection. Obviously, you want it to be very fast, but you don't need a super amount of bandwidth. You just really need to have a high reliability, but it's sort of minimized how much traffic goes over the internet. So also with respect to solo mining, like it isn't, with the typical mining, you kind of just plug these things in. You need a little bit of computer skill, log into Windows and fill out a form, or go into the command line and fill in some values. With solo mining, it's a little bit more involved. So you really want to have some skills around computer networking, administration, engineering, just in terms of wiring everything up. If you're going to use cloud, sort of cloud engineering. And then I think a really important thing is just sort of data monitoring and alerting. You just sort of need to have a way to, that's, I think, the hardest problem in solo mining is because the difficulties are so high, and, you may be mining without finding a block for a very long time. If you're not good with your data, you basically are going to be blind and not necessarily even know if it's working. With a pool, it's working because you can look at the pool and you can see that your balance is going up, because as the pool finds blocks, it sort of gives you a small reward. That doesn't really work in solo mining, where you have blocks coming in very slowly.
Hey,
Yeah.
Mike,
Do
can
you
I
have a
ask
question?
you a quick question on that?
Sure.
If you don't mind, if you go back that last. So when you said you're basically blind, could you expand on what you mean by that?
Yeah, so like I don't know if mine's recording the audio other than what I speak, so I'll just reiterate the question. So basically just expanding on what it means to be sort of blind to your operations. Well, what ends up happening is like if you, take Litecoin for example, or Bitcoin for example, the block you would need a lot of power in order to find a block um, with any kind of reasonable amount of time, right? So like there's a calculator on some pools that you can do, and you can say, here's how much hash power I have, and then here's the network I'm mining on, and it'll kind of compute for you a probability of finding a block, and then it'll also give you like an expected block time. So like you may find that if you don't have a lot of power, the probability that you'll find a block is very low. And it might say that you're on average, what it'll say, your expected block time is maybe a month, right? So the expected block time is a month. That means that you're going to go an entire month without mining a block. So your system's going to be running, it's going to be consuming power, but you won't know if it's really working until you find a block. So it creates a lot of headache and angst where if you're mining and you have this expectation that I'm going to find a block in a month, but you don't find a block in a month and it turns into like 2 months, that's not necessarily indicative that there's a problem. It just could be bad luck, right? Because it's a high volatile, it's a high variance where if the expected, block, if the expected time to find a block is a month, you might need to be prepared for like 2 or 3 months, before you'll actually find a block. It's all about luck. You may find a block in the next 2 days, but you also might not find a block for 2 months or 3 months. So you really need to have a good handle on the data that this is on the system, specifically like the logging, and a way to kind of capture the logging and keep an eye on what's going on. Also on each of your machines, making sure each of your machines are working. So that you don't get into a situation where you find yourself mining, but there's some kind of misconfiguration where you're not actually submitting work, or you're not actually, the work that you're doing isn't making its way onto the network when you find a block. Because that would be the worst thing. You're mining and then you find that when you did find a block, but because of some misconfiguration or something, you messed it up. So I think data being blind is just that, like, there's going to be a period of time where it looks like it's working, but you need to have sort of some skill around data and analytics to just make sure that, yeah, it actually is working. Like the shares that it's finding are actually like working and things like that. So that's kind of what I meant by that. And it's pretty like, I think solo mining the hard way, like mining the hard way is solo mining, just because like, unless you have a facility that's powerful enough to be finding blocks like every couple days, it's really frustrating to go an entire week knowing that you're burning the electricity to mine, but not knowing if it's working because you haven't found a block, right? So it's very high, and that's more or less the reason that I got out of it, was just that it was really high stress dealing with large facilities that your expected block time might be a week, but you might go 2 weeks without finding anything. It creates a lot of stress for everybody because you're spending a lot of money on power, but you're not getting anything back. So I generally don't recommend people solo mine for that reason. But there are plenty of reasons why you would want to solo mine as opposed to like pool mine, other than the fact that like the pool takes a fee. In my experience, the pool taking a fee is so insignificant relative to the amount of angst and work that it takes to mine solo at scale. So I always say, like, yeah, just go to the pool unless you have a really good reason not to use a pool. Which there are plenty of reasons why you wouldn't want to use a pool. But so yeah, I don't know, Laura. That probably answered your question, right?
No, it did. It absolutely did. And at the end, like you said, there's a lot of kind of cost at different levels involved with solo mining. So, I think that's something definitely I would like to hit on the end. Like, why would someone solo mine DigiByte with all of those kind of barriers? But you totally answered my question. Thank you.
Yeah, yeah, and just so I say it back for this recording I have, is like, yes, there are a lot of different costs associated with it. There are reasons people want to do it. I mean, there's definitely like the privacy reason, which is like you don't want to be connected to a pool. You don't really know what a pool is doing per se. So there are plenty of reasons why you would want to do it on your own, because you could like set things up a little differently. So and I kind of have it here at the bottom, just like in terms of what's purposeful, like having the data analytics skill. You really need to be able to interpret the data, specifically around things like monitoring logs. So being able to like parse logs and put logs into charts that you can watch, and make sure that they're still working. Things like that. Alerting for when things go down. That's sort of a system administration task. Because yeah, you don't want one part of the system going down, and then the other parts of the system might just keep working because they don't know that the other part is down, which is totally possible. So yeah, in terms of like operations, things that you need to do as a solo miner, you have to run your own node. So there's no way around that. You have to run whatever network you're mining. In this case, DigiByte. You have to run a node. You also, because the nodes themselves don't do the mining anymore. In addition to running a node, you also need to run your own pool, or your own, what I would say is like Stratum server. So you need something that sort of proxies between your hardware, your mining hardware, and your node, because the node itself does not know how to accept anything other than like a valid or invalid proof of work. So you're mining, you're trying to find proofs. If you find a proof from on your miner, there needs to be some mechanism to take that proof from the miner and put it out, broadcast it onto the network. So unless you write your own middleware that sits there, you're out of luck. All the mining software is pretty much at this point configured to work with Stratum protocol, which is the protocol people use for pools. It's a TCP-based protocol, goes over the internet. But really, if you're running your own node and you have your own miners, so run your own miners. If you have 10 or 20 miners, those 10 or 20 miners need to be connected to a pool that you're running, and then that pool gets connected to the node. And if you can't just connect miners to nodes. There needs to be some software in the middle. All the miner clients are set up to communicate over Stratum. The node itself does not have Stratum baked into it, so you need to run some middleware on it, and that's what the pool is for. And then, of course, the most important operation is just like, obviously, running this stuff is actually not so bad. Getting it up and running is pretty hard, but once it's running, it should run. The problem is that you need to basically keep monitoring everything and making sure everything's working. Recommend setting up like testnet, pool, mine on the testnet first. Make sure everything is working on the testnet before you try mainnet. You can just, this isn't like staking, so there's no cost to just try mainnet, right? The worst cost is that you're going to misconfigure it and you'll be mining, burning energy for no reason. But I do recommend setting up testnet just so you have the assurance that, like, yes, this setup is working and I have all my monitoring in place to know that it's working. So just in terms of, I have a sequence of diagrams now just to give you a little bit more detail around how the setup works, and then I'll end the presentation looking at some of the code and just pointing out a few places where you'll need to make your own configurations. But basically, the network architecture when you're pool mining on like a public pool is you essentially have the network, the internet, somewhere out on the internet is the DigiByte network, all the computers connected, and then one of those computers is presumably running a pool. So what you do on your local, data center is you connect all your mining computers. They all use Stratum, and I'm sure a lot of people who have done mining have seen this before, but you just fill in like the URL, and then you fill in like your worker name. Sometimes you put in a password, though typically these days you don't put in a password. But yeah, so this is the normal architecture. When you do a solo mining architecture, you're basically pulling some of the work that's done out on the internet by a pool operator. You're like local, you're like onshoring that work to your local data center. So you'll still have your mining cluster. The mining computers will still be connected over Stratum, which is really just TCP. It's a remote procedural call, so it's like TCP. It's just Stratum is like a specific way of doing RPC calls. And then what you'll have is you have to run your own pool. In this case, for DigiByte, you have DigiHash pool, which is the pool that you would use. I think it's the only pool software that I have found for DigiByte. And then you also need to run your own DigiByte node. And so you sort of see what I was saying earlier, which is the mining computers, they're expecting to communicate with a server over Stratum protocol. The node does not natively interpret Stratum. It only accepts basically RPC requests and a set of commands that it knows. One of those commands is essentially like submit block or submit solution. I forget exactly what the call is. And then that node has to be connected to the internet. So you do need to like poke a hole into your internet so that, one, the nodes can communicate back to your node, and then two, you can communicate out to the other nodes. So there's sometimes some network configuration you have to do. But this is sort of the high level architecture where you set up these mining computers, you run on a separate server. You have to have some server somewhere where you're running DigiHash the pool, connecting and have configured it to connect to DigiByte the node, and then that DigiByte node has been connected and configured to connect to the larger network and sync and stuff like that. So the next piece would be this is still a simplification of what actually needs to happen. So if we just look at just what's in the server, because of the way DigiByte works with its 5 algorithms, it actually involves running the node 5 times with 5 different configuration files. So in order, if you only want to run and mine on one algorithm, then you only need to run one instance of the node and have one configuration file. But if you would like to mine to all of them, then you have to do a much more complicated setup where you have to essentially run the node 5 times with 5 different configuration files. The only difference is that you can use a single data file. So you could basically use the same. It's not like you need to keep 5 copies of the blockchain. You can use 1 copy of the blockchain and connect it to all the nodes. And then each node has its own configuration file. So it's not necessary that you need to copy the database 5 times, but you do need to configure it 5 times or 3 times, depending on what algorithms you want to use. The other piece of this is the Stratum server. So in this case, DigiHash. So you run DigiHash, and DigiHash itself has its own configuration files. There's more than just one configuration file, but it has its own configuration files. And then basically the 2000, 2001, 2002, these are essentially port numbers. So each of your nodes need to expose themselves on a single port. They can't share a port. So each of your nodes needs to select a different port. Here I just use 2000 through 2004 as an example, but essentially each node is listening on its own port. And then you need to configure the Stratum server, DigiHash, to properly connect to all the algorithms. And then of course you connect your miners to the Stratum server. But yeah, so just a little bit of detail in the architecture here. You do have to, like, depending on how many algorithms you want to run. If you want to run all 5, then you have to run all 5 and configure all 5. So the other thing I have here is just some code, and I'll sort of show you where the configuration lies in these. The server that I would recommend is just using an Ubuntu server, so you can just download the latest Ubuntu server, and that should be fine. In terms of the node, you can get the node from DigiByte directly. I also posted this. This is probably the best instruction manual that I had found. So you can go to this instruction manual, and really I'll just start here. I think everyone can still see my screen here. But basically it goes through, it has all the instructions that you would need to run. And it looks like the case that you could just run these all by copying and pasting them in. But really, the main core pieces of it is there's this whole sort of configuration file. This is one thing that you would need to be more sensitive to when you're running your pool, is because you need to have one configuration file per algorithm. So there's a configuration file. I think I have it. I'm just going to flip over the DigiByte source code. But there's a config inside of the docs in here. Config somewhere, docs config, doc. No. Well, there is a docs directory or doc directory here, and inside of the doc directory, config. I really thought it was just called docs config. May not waste too much time here, but oh yeah, it's conf. That's why I'm not finding it. I'm typing config. So somewhere in here, algorithm. Well, there's an argument for algorithm, so you need to basically, the configuration format is option value. So what you need to do is basically add a configuration element for what algorithm you want to select. So, and I think if maybe I do a full search here for algorithm or algo, it might just be algo. But it will, somewhere in here, there's basically a list of what they expect as algorithms. SHA-256 is SHA-256, and then some of the other ones are different, or maybe it's algo that I'm really looking for. But so yeah, all is to say that if you want to run multiple algorithms, you do need to do multiple configuration files. Other than that, downloading the node is kind of what you would expect. You download the latest version. You would want to update, if you're using these instructions, you would want to double check on what the latest version is. This version number may have changed. And then this is instructions for setting these things to run using Linux system daemon. So this is essentially a utility that I'd recommend using for just running the nodes. You essentially daemonize them so that they'll always be running. You can have processes to just restart them if they crap out, it'll just restart it. And then you can add a whole bunch of other things in here. And then I think that's pretty much, these are your system D commands. So you can just use systemctl, system control, to basically start and stop them, and that'll be work. You can also set it so that it'll restart when it boots up, things like that. And then in terms of interacting with your node, you just sort of have these different port numbers. There's basically some default ports that are set up. Otherwise, you're back in the config here, and you're going to edit some of these ports yourself. So inside of here, some probably port. So different ports for different things. One thing you'll see is this reg test. Reg test just sort of means that you're on like the test network and not on the main network. But yeah, so that's a little bit. I think there's some example. This is probably where the example where you could find the algo. No, I guess not. Anyway, there is a way. You do need to run the different algorithms in here. I guess I'm just not finding the right thing. Shaw, search for Shaw 256. No. Anyway, so that's sort of running the node. I'm trying to think. I don't think there's anything else necessarily in here. If you're on a Windows computer, or sorry, if you're on like a computer that has a desktop, so that'd be like Windows or Mac, or if you install Ubuntu desktop, there's no reason you couldn't run all this on Ubuntu desktop. Then you'll also have access to some like front end. And yeah, there's a few more resources here. So that's pretty much the node. That's pretty much the node. That's probably the easier part. I think a lot of people who have gotten through Solo or have been interested in this have probably already run their own node. So you're probably familiar with that. Main thing to just remember is that if you want to do multiple algorithms, you have to basically configure, you have to run the node multiple times, and you have to configure the node to accept those algorithms. So the other piece, which is a little bit more complicated, maybe a little bit more unfamiliar, is the pool software. So with respect to the pool software, I have run this, so I do know that this works. If you ever run into any issues, you can get in touch with me. But I did verify that this works, and I think I was able to mine on all the algorithms except one, because I didn't have a system or a miner client. I think it's an FPGA mineable token, and I just didn't have something that I could mine with it. But anyway, there are some instructions in here on how to get this set up. You'll see that it's written for Litecoin, but everything the same. It all applies the same. There's just a few different things that you need to add to your configuration. Like for example here, you'll also need to add like the algorithm you're selecting. You'll also need to change, if you're going to mine with multiple algorithms, you need to change the RPC port on each of your nodes. So going back to this diagram, these 2000, 2001, these would be what you would set as your RPC port. So you would basically in here you would set your RPC port differently for each of your different nodes. And I'll sort of show you in the config file where that lives. But you can sort of see there's an example of a config file. This has been annotated, and all sorts of other things. It's talking about a coin config, and then there's a pool config, and then I think this is a network config. So there's portal config, and then there's coin config, and then there are pool configuration. The pool configuration is essentially where it has sort of like the information around which address you want to receive blocks to. You can sort of distribute where some of the rewards are going to go to in terms of pools. So you can distribute those rewards. And then payment processing, the node software here. You don't need to enable this if you're solo mining. If you were running your own pool to make it available to other people, then you could, basically set up a payment interval and a minimum payout, and you can set these things up. You do need to then configure your node to sort of accept that. So you'd want to change these like passwords and things. And then you sort of see ports. You can kind of set up different ports and different daemons. So there's a few things that have to change, and I'll just show you. So this is all just the raw. This pool software is derived from nnomp, which is basically NOMP, I guess, which is a Node.js mining pool. I think it's Node mining pool or something. I forget what it originally said. Yeah, Node Open Mining Portal. So anyway, just to highlight a couple of things in here in terms of the config files. So I'll just show you like pool configs. This is the first place to look, is you have essentially pool configs for each of the algorithms. So in a way, like each of the algorithms kind of function as their own pool. So you have separate configuration files. This is where I would start, is just getting the testnet set up. But like, and I also start with SHA-256 because it's the easiest of all the algorithms. I think you'll be able to find a SHA-256 miner. But you can sort of see that it sort of has the coin config. So there needs to be an associated, for the pool config, there needs to be an associated coin config, which I'll go to in a second. It sort of has payment processing, and then it sets up the ports. So you'll see like here, I'm wondering if I could bring back the sidebar. Close this. Anyway, I'll bring back the sidebar in a second, but you see it's port 3, 3008, 3032, 3256, and then it has its own daemon associated with it, which is listening on port 462. So if I go over to the pool config, let me bring this back. If I go over to the pool config, I'll just open this up in a new tab. Not sure if there's a good way for me to show them side by side, but if I open up the pool config for, so 3008, sorry, when I click on these, it seems to be moving, 3008, 3032, and then 1462. If you look over in the pool config here, you'll see it's different ports. So the script algorithm is listening on port 3013, and then the daemon is listening on port 14050. So I think this is the most important thing, which is like, if you want to have multiple algorithms, you need to run the node software multiple times. And each time you do it, you need to pick a different port for it to be listening on. So here it's 14050, and then here it's 14062. These are sort of arbitrary. When I set this up, I basically kind of changed these to be a little less, I mean, they're not arbitrary, but I basically set these up to be a little bit more friendly, like what I was sort of showing here, where I use 2000 through 2004. So you can just change all these, and that's fine. It doesn't matter. You don't necessarily need to change these. These are the ports that'll be exposed by the pool. So when you're connecting your miner, just like you would to a normal pool, you'll have like a Stratum server, which would be whatever the IP address is of your server. You would just connect it to point it to this port, or this port. Things like variable difficulty have to do with sort of like balancing. It'll try to adjust the difficulty to reduce network communication. So that's sort of your pool configs. As you see, you have 5 of them that you have to configure. You can also just disable. So I think you can just, if you're only going to mine one algorithm, I think all these by default are enabled false. So you can just disable the ones that you're not going to mine. And the other piece you would need is the coin configs. Coin config, I think, is a lot less configurable, but basically going back down to the testnet SHA-256, you see it really just has, it's very minimal. But the way that the pool software has worked is that your pool configs expect there to be a coin config. And yeah, the coin configs are very simple and straightforward. They just sort of are a little different. So yeah, that's pretty much it. Once you get this up and running, there is like a front end for it. So there is a bit of that's running on port. One of these ports will essentially be your front end. But yeah, so your website will be running on port 80. So whatever, and this, if you are using if you're hosting this publicly through DNS, you can sort of set that there as well. The last thing I think I would say is that there are a bunch of passwords in various places. I would always just recommend using like a strong password, because this is a mining pool. Your node will actually accumulate funds. Like your wallet will have real money on it. So if you're accumulating the funds there, if you just use a really naive password or don't change these passwords, and any malware gets onto your pool server, I guarantee you the malware knows what a pool server is, and it's going to look for things, or it doesn't know what a pool server is, but it knows what a DigiByte wallet looks like, and it'll immediately find it, and it'll take the funds if it can. So yeah, that's the last little bit. That, I mean, this is sort of like the high level diagram. So maybe I'll like leave this up. But that's sort of all I have. And yeah, if you have any questions or anything, you can always get in touch with me. And I'd be happy to kind of help you troubleshoot whatever it is. But yeah, that's all I have. Does anybody have any questions or anything? Yeah, you're welcome. mean, the most obvious benefit is getting rid of the pool fee. So whatever pool you're working on is obviously taking a fee, and like if you scale that up, like for a single person with a couple miners, maybe you're making like a couple $100s a month in mining. That equates to whatever they're taking, even if they're taking like a 3% pool fee, it's just a few dollars that you're losing. But if you scale that up by a couple zeros, now suddenly you're spending thousands in pool fees that you could theoretically be making back yourself. And so it might make sense to set this thing up, especially if it's just like a marginal cost, like you already have all the computer engineering skills and monitoring skills that you need. Why not just like it's not like we have to spend any more money. We just need to spend a little bit of our time to get that set up. So yeah, that's one reason. I mean, the other reason is just around, I guess, just the whole ethos of like, like being, not centralizing in the sense, like, if you don't want to create a centralizing effect, like you want to have some miners on the network that are, if you're just like that, that's kind of something that resonates to you and you want to do it. A big reason I think solo mining is worthwhile to just try would just be purely for like experience purposes. I have found that going through the process of setting up a solo mining situation, just like you have in this architecture here, is actually a really good training mechanism to teach you a lot about networking and Linux and computer systems. So I think that that's a benefit of doing this too, is it'll just make you a better engineer, better computer systems administrator and things like that. And then I guess the last bit is just around the privacy aspect of like, from the external world, it just looks like you're running a node. Your node is periodically like broadcasting things about, it's finding blocks. But for the most part, it's not like your internet traffic is a bunch of pool communications. Like you're not connecting to a pool. Your node, like, and that might get flagged on some networks, like where it sees you're connecting to DigiByte pool. I don't know if that's a real pool, but you get the idea where it's like digibytepool.com. This person is connecting to digibytepool.com all the time. It's like, why are they doing that, right? And then maybe we can go to digibytepool.com and ask, hey, we see this traffic. Can you tell us a little bit more about it? Especially, people get that kind of visibility if you're not using some kind of like HTTPS or SSL end-to-end encryption thing on your network traffic, which a lot of miners don't do that. So, it's a little bit of a different network situation where instead of being connected to a pool, you just show up as connecting to a lot of different IP addresses because you have to kind of peer-to-peer, connect peer-to-peer to other ones. The other thing is you can set up your node to connect to the network using something like Tor. You could connect your node, you could run a node, connect the node to Tor, and then in that case, it's going out and it's connecting to other nodes, and it's not even visible on the network what you're doing, and then you can mine or whatever. But yeah, I mean, the main benefit, like I said, is the fees. And then beyond that, there are like niche reasons why you may not want to connect to a pool, and that kind of thing. So, yeah, and then obviously like the trust thing about a pool, like is a pool actually like a pool? With a pool, they have the option to essentially do like a block withholding, where like you could submit a valid proof, and once the pool operator has that valid proof, they could essentially just submit it, but then never tell anyone that they submitted it, right? So there's a possibility of like share shaving, like where like some of your pool shares are just not getting credited to you, or you don't have any way of verifying if the pool is not cheating you. I think they're still kind of working on some algorithms around making sure that things are fair. But yeah, those are that's probably enough for that question. Yeah, sure. Yeah, and then the other thing is running your own pool, you can open it up to other people. So like I've always thought that a good architecture would be like more of regional pools. where you're not, it isn't the case that there's just like one, two, three big pools, but you have like regional pools, and people are more or less opting to mine on those pools because they're within their region, like geographically, like and you see that has become popular with the Foundry pool, as far as I know, is like a lot of people mine on that because it's like US based, and like they, so there's a lot of opportunity there. I think if you have some clout in a community like DigiByte, and you know that like, oh, if I set up a mining pool and used like sort of my social media or like my brand to sort of promote it, people would switch just because they know who's running the pool, and they're okay paying the fee because they know that the fee is going to someone they know, right? As opposed to just going to these like monolithic pool operators that are more or less faceless, like nameless people. So yeah,
I have a quick question, Mike.
yeah, no problem. Go ahead.
This is a hypothetical. So let's say, you've got some solo miners out there and it's not like, they're competing against big pools, right? So it's not, maybe economically they're the like leader of the whole situation. But what if like one of those pools, and this is just a hypothetical, I'm just curious. What if there was like a major pool that went down for some reason? Does that does that automatically like increase those solo miners opportunities to earn? I was just kind of curious, like what
Yeah, it
happens if
definitely
like
does. I mean, it's a function of like network activity. So like let's say that the thing is, first of all, most mining clients allow you to configure fallback pools. So it's not necessarily the case that if a big mining pool went down, the network hash rate would be changed in such a big way. Because for the most part, miners would have a second pool configured
mm,
to some other pool, so they would just switch over. So, but it is to say that like if a pool did go down and if a portion of hash rate fell, that would immediately result in more. Well, it wouldn't immediately result, but it would slowly result in more payouts to smaller pool operators or the other anyone else mining on the network, just because of the probability there'd be a lot less people trying to compete, and so the difficulty would come down a bit. Um, but yeah, and yes, that's a good point.
okay. I mean, it was just one of those things I always wondered. I'm like, what would happen if? I mean, who knows what's going to happen? But thank you so much. I've learned a ton today, like a ton. Um, I don't have any other questions. I thought you did a good job really laying it out.
Yeah, great.
Jose, John, do you guys have any?
I wonder if you want to start your own pool, Mike, can you give me kind of maybe some rough estimates of what it might cost and, determining what kind of scale you want to, have it at? Is it something simple as like running it on a VPS somewhere or
Yeah, it is. It's definitely that simple.
uh,
It's very low. It would be low cost. You would want to probably spec the machine, whatever the node requirements are. You would
yep,
probably want to scale the node requirements by like three or four or five times just to
sure.
have like surplus capacity. But there's no reason I don't think you could get away with like $100 a month node or a virtual private server, like under $100 a month and getting that set up. You could also run it like how I ran mine was on a computer at my house. Granted, I wasn't letting the world connect to my computer on my house, but you could even do that if you wanted to you'd want to change your internet plan to have a plan that would let you do that, because a like a retail plan doesn't let you like run a service like that. Whether or not they're going to know and shut it down is another thing, but you should get like a business plan that'll allow you to like run a server. But so yeah, I mean, it's not terribly expensive. $100 a month I think is a good estimate. How does that scale? I don't know. I mean, like when we were doing it, I was using AWS. AWS was a good way to go, and yeah, I mean, I don't really know what you're spending, but it scales pretty well just because of the variable difficulty. So like it won't it as people connect, it'll basically like tune the difficulty down so that they're not spamming your server with a lot of work. there's work to be done. So you'll see the CPU, and you can just sort of monitor CPU utilization and memory, and you can just as things change, you can just increase it a little bit, add another CPU, another 2 CPUs or whatever. But yeah, I mean, you could probably even get started with like a $25 a month server, so long as it's it's set up to run DigiByte. But yeah, it's really, I don't think that terrible of an expense to do it.
So if you want to do this kind of at scale, would you create like a primary and a backup?
Yeah, you would exactly. So that's where we were at, which is basically you would want to if you I don't know if it caught it, but there is, if you notice like the list of daemons here, this
Yeah.
is for basically high availability. So like, in a data center set up on something like a cloud host, you would have like one node running a daemon, and then presumably in another like availability zone, you would run the node software there too, and then you have two of these here. So if one was unavailable, it would use the other one. And then similarly with it's not really quite set up here, but you can run the pool software twice and then introduce some kind of load balancer in between there, such that it'll like balance the load across those nodes.
Okay.
Yeah,
Now,
because it doesn't really matter. Like if you have two pool like setups, if you have it, you can have them sharing the same database. They're sharing the same database, so it doesn't matter if someone comes in on the pool that's hosted in the New York region or the pool that's hosted in the San Diego region. It'll just hit one of them, and both of those pools are configured to sort of go to the same database. And you can, with cloud computing, you can pretty much get high availability on databases with like a click. So you can like do a click button and say, I want this database to be high availability. And then, but yeah, you would want to do that. Like that's what like enterprise grade pool operators are doing, is they're running everything in high availability, just because the cost of being down is very high especially if you're serving a lot of people, because they're all spending money on electricity. And if your pool goes down, sometimes it's the case that the miners don't know that the pool is down, because the pool isn't set up to tell them it's down, and so they just keep sending them work, and it's just not going anywhere. So the work is happening, but it's not resulting in rewards.
right.
So
So essentially, they would have either in their, the firewall set up some kind of load balancing or fault tolerance,
yeah,
and
that's right.
they would do that at kind of autonomous circuits, right? Like you put one in Linode and one in like DigitalOcean or something, right?
Yeah, I mean, yes, exactly. If you wanted to go with two different cloud providers, I mean, you could kind of just set up like a multi-cloud, like within one cloud provider, you could just use availability zones, and that I think is enough, probably sufficient. But yeah, you could do it across two node providers. Somewhere you're gonna have to run the infrastructure that's like the firewall that puts it out there, or like the switch that's people are connecting to. So, but yeah.
And then in terms of mining it, like what is like I wouldn't say optimal, that's not the right word, but what is like you wouldn't want to mine it on a PC, right? Because that's not really going to yield you much. Right?
No, at this point, I think all the algorithms for this, you would want special hardware to actually have any kind of like economic efficiency. Um, like, yeah, you're gonna on the main network for DigiByte, because it is so competitive that like if DigiByte becomes profitable for SHA-256, most of the hash power will just profit switch onto DigiByte. So there's this constant load on the network or there's a constant load sitting out there that's being profit switched around from network to network. So you would need to get competitive hardware if you really wanted to, make it worth your while.
For SHA-256, right?
Yeah, for all the algorithms, because that profit switching happens for every algorithm. So
Is that
that there are marketplaces where, and this is another thing I should add for like pool operators. There's basically marketplaces where you can buy hash power. And one of the people will be like, well, why do you buy hash power? One, it's basically a commodity, so people trade it. But two, it's actually really useful for pool operators to test their pools, because what you can do is you can go on here and spend a little bit of Bitcoin to buy like a petahash or like an exahash, right? And you can buy it for just like 20 minutes. So for like 20 minutes, you can point an exahash of power at your pool, and you can verify that like, yes, my pool is able to handle exahash. right? It costs money to do that, but you can do it, right? So yeah, that's another thing I think that's useful to know is like this nice hash tool is really very good just because there is a marketplace. You can buy the other algorithms. Like Qubit is one of the I think they're all on here, but you know, you have Script, Qubit, I forget the other one, but so yeah, there's these this is a way that you can get hash power without buying hardware. So like as a pool operator, when you want to test things, you would just invest a little bit in buying hash power and pointing it at your pool and just doing a load test for like however long you want it to do. So yeah, it's a good way to go.
Yeah, I might ping you about, have some questions about creating a mining pool. Don't
Yeah,
want
I'd be happy to help. If you're ever trying to get it set up, you know, I could definitely help you get everything going.
to. I
Cool.
assume
Anyway,
that because these JSON files have the passwords in it, you're compiling this, right?
no, those files just sit on your server. It's one reason why you want to like be careful. They're not compiled into it's Node.js, so it's not really like a compiled into something. Um, and I don't think that it's configured in such a way where you can set environment variables either, which is why you want to basically be really careful about the server. Like I said, if somebody gets in there, obviously they're just going to look for your wallet.dat, your data file for your wallet, but they're also probably going to look at everything else that's in there. So you find these things in here. So yeah, it's just a little. You really just want to like the pool server that's running. You want to just make sure it's secure. That's why like putting like using like a load balancer and a firewall in between that, and not just connecting directly to the node is a good idea. Um, Doing all the security things. If you're really at scale, putting in like malware byte detection or malware detecting software and things like that, just to make sure that like you don't install anything bad or nothing bad ends up on your server. So.
Yeah, I mean, maybe there should be a script that'll just lock down all the ports minus the ports for all the nodes in the pool, and that way,
Yeah, I mean, by default, yeah. If you set up something on a cloud, and it'll be pretty secure, and yeah, you should be fine.
so yeah, if you set up a VPS, it's only going to open up the ports that you tell it to open up, right?
That's right.
Okay, good. Interesting. Looking, I think when this is something we've been talking about. I think this is something now we can kind of kick the tires a little bit and test this, especially on testnet. I don't know who's mining on testnet, but I think
Yeah,
we
no,
need.
you can find blocks on testnet with just like your laptop. Like you
Right.
can run a SHA-256
No
miner
one's
on your.
mining on testnet, so you don't
That's
need
right.
advanced, hardware.
Well, there are people mining. There are other pool
Yeah,
operators that are also testing on there, I'm sure. But yes, you get the idea, which is like it's not competitive. So like
right.
if you just run, there was I think one algorithm that I think that's the problem. That was the problem I ran into actually. I think I could find mining clients for all of the algorithms, but it just seemed like someone was testing on the test net with a like FPGA or A6 miner for one of the
I
algorithms.
think it wasn't that Odacrypt, Mike?
Probably Odacrypt, yeah,
I think
something.
it was
But
Odacrypt.
But because there was someone out there, it was too competitive that my machine never found anything. So I like ran it for like a week or something, and I just never found anything for that. So you might run into that situation, but like I said, I would test with SHA-256, and then I would try to get script running. Those are the easiest in terms of like the most well-known algorithms for miners. If you get those two working, then getting the other three should be fine. That yeah, testing the Odacrypt one I think was like it I could confirm that it was mining, but I couldn't confirm that it would actually find a block because it never found a block for me to test.
Like on what to mine, it'll tell you like the profitability of the algo. Do they
Yes.
have something that would like automatically switch over for you, or like,
No, pools, I think that's more there. I haven't seen anything like that in the open source world for pool software, like an open source profit switching pool. I think there were for script. So Node pool has been heavily modified, I think, to work with these specific algorithms. The 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 higher level node pool, if I go back here, well, wherever the other like node pool is, there's like a core node pool, node mining pool, node open mining pool. So this is like zone 1186. So basically this is the more like maintained one that people fork. So people essentially fork this one out. But there are other pool. This doesn't have all the algorithms. I think if you look at coins, there's like a lot of coins are in here, but they're not all in here. And then because DigiByte has the 5 algorithm switching, I don't think it shows up in here at all. If it does show up, it might just be connected to the old DigiByte. I don't know. See, yeah, back when it was script, right? So it's still configured to just work with script. So they never implemented the 5 algorithm rule, but that's where the DigiByte DigiHash steps in. Is DigiByte has whoever this is originally, I think, created it. Jared Tate maybe or something. So he forked it, and then or someone, I don't know, maybe it was DigiByte Core forked it. So it actually does look like, yeah, so they're ahead. So it looks like they have added that. So, but I haven't seen the profit switching. I think you'd have to figure that one out on your own. Yeah.
Yeah, but at the very least, we can test, the release candidate 8.22 mining on that candidate. So
That's right. Yeah, I think what when Laura originally hit me up about mining, she was asking if I could do that, and I was able to do that. I was able to verify all of them except the Odacrypt one, and the blocks were producing just fine. I was receiving my testnet DigiByte. I don't remember if it was 8.22 or whatever, but whatever the version was, I was using that node version, and it all worked fine.
okay, so was it the release candidate version or was it
I think
the
it was the release candidate. I think at the time it said RC.
okay?
What I was downloading. I forget exactly. How
Yeah.
long ago is this? February 3rd? I don't know, Laura, when did you ask me about it? I thought the weather was still warm when you asked me about it. It might have been this one, April 2023.
Right. This
'Cause,
one's
yeah.
good. No. It would be the one. It would be RC3, no?
Well, I think I did this. I remember the weather was warm when I did my test.
Oh,
So
okay.
I think I used RC2. I don't think I wasn't doing the pool on the 3rd. This is too new, so I definitely wasn't using this version. I think my test, I forget when, Laura, you asked me about it, but it was definitely when the weather was warm last, and that was probably around the spring sometime. So it was probably this version that I was using.
Yeah, there's some merged files in RC3 that's in development.
Yeah.
I'm gonna ping you and have you test
Well,
that.
yeah, if you ever need some help with that, let me know because I could
Definitely.
spin that. I was hoping to be able to get into my server and show you guys. I just lost the hard drive. I looked at like 2 hard drives thinking I would find the old one that I used with this on it, but I guess I can't find it. But yeah, it was easy enough to set up. I remember how to set it up that I wouldn't mind doing that again if you need it.
Awesome. Yeah, we're gonna need people to test the mining aspect of the release. Okay, it's
Cool.
exciting. That's great.
Yeah, happy I could help. Any other questions? Cool. Um, Yeah, I guess I could share these slides if you want. This is no reason I can't make this available to anyone. Great. Great. Yeah. All right, cool. I'll just gonna put that presentation in the mining channel, I guess is probably the best place to put it. So if anyone's curious, they can take a look. Great. All right. Yeah.
Thank
Anytime.
you, Michael. Appreciate it.
Yeah. Yeah. Keep in touch. Bye.
So we met actually before the Alliance nonprofit was announced. Okay. So we did a lot of like pre planning and filing of things before we actually announced ourselves publicly, right? So Rosetta was one of those things that we were looking at, trying to support. And Wyoming blockchain or Wyoming University, the University of Wyoming was doing a hackathon during their like Stampede days.
Right.
And so we were like, well, if we could participate in that hackathon, then maybe we can find a Rosetta developer. And like this is like what, 3 years ago, probably,
I
Mike?
think it was 2022.
Was it 2022? Anyway, it was years ago, and it was again before we had said anything publicly. I mean, privately, some people knew we were developing the nonprofit, but we didn't want to say anything publicly. But we didn't want to miss the opportunity, so we put up a challenge and a bounty for this hackathon, and we were like, "Oh, this is so awesome! We can do it remotely because none of us are in Wyoming." And everything was going great, and it was literally, I think, 12 hours before the hackathon that we got a message that we had to have somebody physically there to represent our county. And we're all, none of us are there, right? And we're not going to get there in 12 hours. And so I texted a friend of mine, Nathan Hawk, and I said, do you happen to know? I said, I know this is a long shot. I said, do you happen to know any developers that are in Wyoming right now at the hackathon that could help us with this? I mean, that has to represent DigiByte, right? Like, so I was like, this is a long shot. And so I messaged him and he got back to me right away. He's like, yeah, I've got a friend, Mike, who's in Wyoming and at the hackathon that said he would be interested in doing it. So like I immediately called Mike. We connected like within 5 minutes, and he was like, "Yep, I'll do it." And we had gotten these VIP tickets because we were. I mean, obviously we weren't there, but we were, participating. So
Oh
we were like,
yeah,
"If
I
you,
got to go to the V. I remember I got to go to the
yeah,
VIP party.
yeah," and so I was like, "Could you possibly do this?" And I was getting ready to go through the whole spiel of what Digibyte was, and Mike goes, "Oh yeah, I know what Digibyte is."
I
And
know
then
it
Mike,
did. Yeah.
I was like,
I
"Are
think
you
you had
serious?"
something written too. There was like a chat, and I basically I remember just read
Yeah, we
the.
had a
I
challenge written up for Rosetta.
right. But yeah, I was very familiar with DigiByte because I was mining. So out back in the day, like script mining was DigiByte was always one of the ones that was like, in the profit switching pools, you would always see it was always kind of coming back to DigiByte as one of the profitable script algorithms to do. So yeah, I was familiar with it and had downloaded a DigiByte wallet before, and so and just like all the other proof of work chains. But
Yeah,
yeah, it
so
was good.
that's how Mike and I came to meet. And he presented for us. We have him on video. Like they had the whole thing, live streamed, and he did a great job. And I was just like, wow, this is going to be a friendship, a special friendship with Mike. I think
I was so happy too because
you saved us.
I was in Colorado for a different event. My friend had just said like, "Hey, there's this." I was actually just in Colorado in February for ETH Denver, and then I think this was a couple, maybe the next month or something. And so I came back to Denver for something else, and saw that this was going on, and so I had rented a car from Denver, drove whatever it is, like 2 hours up to Wyoming. I did not even have like a place to stay. I had to like call, and there was the Cardano conference, and everything was
Right.
just packed. I called all the hotels, and only one had a room left, and it was like one of their like suites or something. So I had to get that just because I like did need a place to stay. But during the thing, I wasn't even expecting the hackathon. And then when I found out the hackathon was going on, I was like, oh, well, I'll check that out too. That's even better because I'm not really into Cardano. I just wanted to get like a pulse on the community there to see like what are they up to. And so yeah, and then you hit me up, and then from that I got to hang out backstage and met some like more interesting people in the community, like some of the leaders in the community. And then I also got the VIP, went up to like the box or like they had it at the football stadium, which is like a really nice stadium. They had it in the VIP box up at the top, and it was like catered and everything. And then was there another perk I got out of it? I forget, but no, it was
I don't
really good. The
know.
only problem was
It was
nobody.
definitely a win-win.
Yeah, none of the developers I talked to, because I walked around and talked to all the developers, and none of the developers there really had enough skill like to do the Rosetta thing, because I think it was in C++ or it was some harder language. So like most of them were just web developers and students, and so yeah, there was one person who's like, I'll take a look at it, and I followed up with them the next day, and they were like, it was a little too confusing to figure out how to get started. I was like, okay.
Yeah, it's definitely it's a you know those kind of developers are not growing on trees.
Oh, the other
But
perk I got was the other perk. That's the other perk that I got was going
what?
out to the bar where all of because I had been hanging out with the VIP people, I got to learn where they were all going after the whole thing was
Oh yeah.
over. So I ended up going to that, and there was a lot of like influencer type people, and like Charles Hodgkinson was there, and it was a great time. It was like a cowboy bar. The town Laramie was really cool. So yeah, that was the other perk, is I got like the inside scoop on where everyone's gonna go. So
Yeah, that's how those conferences work. Yeah, I'm really hoping to go to Laramie this fall because they're doing it again, and I've been wanting to go for the last couple of years, but I think it's my bucket list for 2024.
yeah, I think I'm gonna try it. I would like to go back and try it just because I really liked the town there.
Yeah,
So yeah, you'll have to keep me posted on when that pops up.
I
I think
definitely will.
yeah.
We could actually meet in person, Mike. What?
Yeah, what? Crazy, right? Yeah, I'm sure there's other stuff going on too around
Okay,
that
so
time.
that's our background, guys, between me and Mike on how we first got connected.